Hello everyone, welcome to the next lecture on the numerical methods MATLAB code. Today we will discuss about how we can define the Newton divided difference formula for this numerical method, and it's a part of the interpolation step. Myself Dr. Garg, working in the School of Mathematics, Thapar Institute, India. So what is the objective of this short video is that, like here, you have to find the value of the f of 3 from this tabular information by using the Newton divided difference method. So all of you know that how you can solve it manually. Once you will solve it manually, you will get this answer. So this is the divided difference table, and how you can compute this value 13. So all of you know that if you have this information, like it's a given information, how you can compute the first number is, that is a 14 minus 1 divided by 1 minus 0. So it gives you 13. Similarly for next one is 15 minus 14 divided by 2 minus 1. This will give you 1. Similarly for here, it will be 5 minus 15 divided by 4 minus 2, and so on. So once you will perform, you will get this information, that is xi minus xj over here. So it is denoted as a dd1, that is a divided difference of the first one. Similarly, how you compute the second one is, you can use them here, like 1 minus 13 divided by, now it's a second difference, so you have to take 2 at a time, that is a 2 minus 0, so it will give you minus 6. Next one is here, minus 5 minus 1 divided by 1 and 4, that is 4 minus 1, it gives you a 6 by 3 minus of 2, and so on. That is called as the second divided difference, and I denoted this as dd2. Similarly, you can compute the third one by using here, this is minus of 2 plus 6 divided, now it's a third difference, so you have to take 3 at a time. 4 minus 0, it will give you 1. Next one is 6 minus 2, so 1, and taking 4 at a time is there. So once you will do that, you will get these expressions are there. And similarly, you can compute for the kth, that is for the nth, and I call as this as a ddk, that is for the kth, so third, and similarly for the fourth order. So all of you know that this is, you can solve it with the help of manually. Now how we can solve it manually or in terms of the MATLAB. So finally, once you will construct this table, then based on this you have to construct the polynomial with the help of here. I can call as this as a dd1, this as a dd2, I can represent as here, where what is the dd is our, I can write is, this is the summation of this, so this is the first term, this is the product, and summation I can write here. So this is the expression I can write into the MATLAB file for computing the values using Newton divided difference. So let's see on the MATLAB window how you can do that. There's a very short 3 to 4 lines our code is there. So since my target is to print this output table, so what you can do is, so firstly you have to print input this value of the x. So according to your own problem, if you have some different information, you can change the value of the x here. So you have to input the value of the x. Finally, I call this as a y, so you can input the value of y also. Then you have to think about that how many numbers are there, because accordingly you have to subtract them. So how many numbers are there? There are the 6 values, so you can use the xr here. Now once you are finding the Newton divided difference at the point 3, so I call as x is input the number of value of the x, or you can also write x is equal to 3. Why 3? Because I need the value of f of 3. If you want to calculate the value of the f of 10, then you have to, instead of the 10 you have 3, you have to use the 10. But if you want to user define, you can use the input the value as here. After that, you have to think about the number of the data set here, how many data sets are there. This is 3, 4, 5, 6, so it will give you the 6 answer. Then in order to construct this table, now this I will define this as the zeros of the n cross n. So look at that, if I run on the MATLAB file, what is the meaning of this? So if I clear here, if I consider as n is my 6, then if I write here as a 0 n comma n, it means it will give you a 6 cross 6 matrix where all the elements are 0, like here. So I initially put all the elements are 0, and once we will compute all this new value, we will fill them. How we can fill them? So I can construct this table. So this first value is my y, so I can save this value in the first column, that is a y, because y is written in the form of the row, so I can transpose them in here. So if you write these values in the MATLAB file here, look at that, if I write this value, it will give you the first column 1, 14, and so on, so like here. how you compute the second value? So how you compute the second row, second column, third column? So we use this formula. Remember that now since divided differences start from the second column, look at that, the first column is stored for the value of y. So now we work on the second column, that is column wise I denoted as a j. So this j is starting from the 2, and last one is we can compute to the n. So we can start from the 2 because divided difference first column is already stored, so we can start from here. What is the value of the I is, I can row wise, so we can start from the first, and what is the last value is there, this is the maximum value. So I can compute the value of I from here. So what is the value of the I is here, this is n minus here. So this is same, n minus j plus 1 is there. Now I can write this expression, you can write this simply. So we can write it in numerator part, divided difference, because we already store in the form of the zeros, I plus 1 j minus 1 minus divided difference I and j minus 1. Similarly I can write in the denominator part, I denote it as a den of this. Finally we can save in the form of the divided difference I comma j of numerator divided by denominator. Once you will write here, you can end this file. So once you will run up to if you run this file up to here, you can see I can write the dd here, you will get all this output. Look at that, the first column is 1, 14, 15. You can see the first column is same. You can see my target is to make this column. So the first column is same, second column is 13, 1, minus 5. You can see these values are there, 13 minus, and rest values are 0. Similarly minus 6, minus 2, 1, 6, rest values above and below are 0. 1, 1, 1, rest are 0. This is 1, 1, 1, rest 0, and all others are 0. So based on this you can construct the divided difference table. Now the second one is, after computing the divided difference table, your target is to find the value of f of 3 or f of 10, f of 9, whatever you want. So how you can use them? We will use this formula. So in order to write this formula, so look at that, there is a one loop for the I, second is for the j. So we can start from the one loop. I can consider here as this is my n, you can write here as n also, n minus 1, but here I use as n. Why? Because once you will write this expression, you can see that I can write as a product. So this is product x minus xj. So j varies from 1 to n, so I can write here as a j varies from 1 to n. And divided difference of I is I plus 1. So since I written as I plus 1, why? Because my divided difference start from the second column. Now since it is I plus 1, so that's why I have written here maximum value as a n minus 1, because once n minus 1, it will automatically become say n. So it will give you this expression. I can clear this screen for you. So this will give you this expression I have written here. Now what is the remaining task is, you have to put the summation and then you have to add the first element. So you can simply take the first element, that is a y of 1 plus sum of this. So it will give you this answer. So this is the final answer, you have to save that. Now in order to print this divided difference table, you can use them as a array to table dd. So it will give you, look at that, if I write for you here as array to table dd. So this is also output, but you can see there is no heading of these columns are there. So if you put them here, so this is the divided, this is the first value, first column of this is second column, third column, fourth column, fifth and sixth column is there. So finally you want to print the output, the value of the y at x is equal to this is here. So you can see, if you want to see, I can copy this each line here. This is the x value, input the value of the x. I have written the each code here. Now once you will click on this run, you will see, you will get the enter the value of the x. So now my task is to value of the 3. So if you click on the enter, this is the divided difference table, and the value of the y at x equal to 3 is given to here 10. So if you solve this question manually, you will get the value of the f of 3 as a 10. On the other hand, if you want to calculate the value of say f of 7 or f of minus of 9, what you can do is, you can simply run this file again. You can run the file, you can see the enter the value of the x. So say minus of 7, 6. So add the minus 6, this is the divided difference table, and the value of the y as minus 665. So this is the simple way you can construct this Newton divided difference MATLAB code. That's the end of the MATLAB. I hope you can learn this session also. If you find another videos on the numerical methods MATLAB code, you can simply click on this link. Till then, best of luck students. Happy learning.